Ever looked at a mountain of numbers and thought, yep, this makes absolutely no sense to me? Trust me, we can all relate to this, but that's where histograms come in. Before we dive in, here's what you'll learn today: what a histogram is and why it's a crucial data visualization tool. When to use histograms in your data analysis. How to create a histogram in 4 simple steps. Practical tips for choosing the right bin sizes. Common mistakes to avoid when creating histograms. How to interpret histogram shapes to extract meaningful insights. Ways to compare histograms with other visualization tools like box plots and scatter plots. Real-world examples showing how histograms solve actual business problems. If you like the insights, don't forget to subscribe or leave a comment below. Histograms take your confusing data and turn it into something that actually makes sense. In this video, we're breaking down the histogram, what it is, why it matters, and how it helps you actually understand your data. This isn't just for data nerds. Whether you're dealing with pizza quality, customer reviews, or repair times, if you've got the numbers, this is for you. Let's go. What is a histogram? Think of a histogram like a bar chart for your data's personality. It shows how often certain values show up by grouping them into bins, which are just ranges of values. Each bar represents a group of values. A taller bar means there are more values in that range. So for example, let's say you've got 100 repair times. Instead of staring at all 100 numbers, you just look at the histogram and instantly see that the bar with a range between 40 and 60 minutes is taller than all others combined. Boom, pattern spotted. You now know that most repairs take between 40 to 60 minutes, and you didn't have to go through any spreadsheets. Why are histograms important? Data is pretty much useless if you can't read it. Histograms show you where most of your values live, whether your data is spread out or in a small range. If something weird is going on, like outliers or sudden spikes. Quality experts use histograms to spot defects, managers use them to make decisions, and normal people? Well, we can use them to stop guessing and start understanding the data. Visual clarity. Histograms are excellent tools for making data analysis clearer since they show data distribution in defined intervals. By organizing data into bins, histograms help reduce the confusion from individual points and present a tidy view of how values are arranged. Anomaly detection. One of the biggest benefits of histograms is their ability to help you spot unusual patterns or outliers in your data. When something doesn't fit the expected distribution, it stands out visually, allowing you to investigate further, inform decisions. With a clear view of your data's distribution, you can make better decisions based on what's actually happening, not what you think is happening. How to build a histogram, step by step. It's easier than it sounds. Let's break it down. Hey, 1. Collect your data. Say you're gathering customer satisfaction scores from 0 to 10 or repair times measured in minutes. You need a good sample size. The more data points, the more accurate your histogram. For example, technicians might record 100 repair times throughout the day, 81, 69, 58, and so on. 2. Choose your bins. This basically just means deciding on the grouping range for each bar, like 2, 3, 4, 5, 6, 7, 8, 9, 10. You can pick any grouping that makes the chart readable. The goal is clarity. Not every chart needs to be perfect. Just make it useful. There are actually some mathematical rules to help you choose the right number of bins. 2 to the k rule. Find k so that 2 power k equals to n, where n is your total number of data points. Square root rule. Set the number of bins equal to the square root of n. Rice's rule, calculate k equals 2. 2 multiply n power, 1 divide by 3. For 100 data points, these rules suggest about 7 to 10 bins. But remember, you can adjust based on what looks clearest. 3. Plot your histogram. Your bins go on the x-axis, and on the y-axis, you have the frequency, which tells you the number of scores belonging to each grouping. The height of your bars will depend on the frequency. Keep bar widths consistent and label your axes clearly. Data range on the x-axis and frequency on the y-axis makes everything easy to understand. 4. Interpret the results. Once you've made your bars, this is where you get all your insights. What grouping of scores has the highest frequency? Are there any outliers? Is there one very tall peak, or is it more spread out? Is the distribution symmetric, skewed, or bimodal? A symmetric shape often means a normal distribution, while skewed shapes may point to outliers or other patterns. Real-world example. Let's do a tasty example. Our 0 defect pizza wants to track quality. They rate pizzas from 0 to 10. Anything from 0 to 4? That's a bad pizza. 5 to 10, ranging from just okay to absolutely delicious. They check 100 scores from customers. The histogram shows that 20 pizzas land in the 0-4 range. That means a 20% rejection rate. Yikes! Now they know something's wrong and they need to tweak the recipe, maybe retrain the staff, or even check the oven. The histogram might have just saved their business. Limitations and best practices of bin selection matters. Histograms are powerful, but they've got some quirks. The size of your bin or range matters. Too few bins, you might miss important details. Too many, it might be harder to notice patterns due to outliers. Please maintain bin sensitivity. Small changes in bin width can drastically alter how your data appears. For example, changing bin width from 5 to 6 units can completely change the visual interpretation of your data. This shows how sensitive histograms can be to even minor adjustments in bin size. Try different approaches. A helpful idea when using histograms is to try different bin sizes to find hidden patterns in the data. Changing the width and number of bins can reveal small trends, groups, or gaps that might not be clear with just one setting. Normalization. When comparing datasets of different sizes, normalize your data. Use percentages instead of raw counts. This ensures a fair comparison between datasets that might differ in size or range, preventing one dataset from dominating the interpretation. Combine with other tools. You compare histograms with other visualization tools for even deeper insights. Histograms versus box plots. Histograms show the shape and spread of data distribution. Box plots highlight statistical summaries and outliers. Together, they give you both the big picture and the key statistics. Histograms versus scatter plots. Histograms show how one variable is distributed. Scatter plots reveal relationships between two variables. Use both to understand not just your data distribution, but also how variables might influence each other. Check out our video on correlations chart and scatter plots for more insights. The bottom line here is that a histogram is your best friend if you use it right. So the next time you're handed a chunky data set, don't panic, just build a histogram. It's quick, it's visual, and it's smart. It turns messy data into meaningful insights. That's it for today's video. When was the last time you used a histogram? What do you plan on using it for? Let us know in the comments. Don't forget to like, subscribe, and stay tuned for more amazing quality content.